Okay, page 14, percent composition. Conceptually pretty easy. Once we take it and add stoichiometry into the mix, can become a little more challenging. But so on page 14 at the very top of the page, what you're going to see is you're going to see a percent composition, you see a formula. So first of all, let's go ahead and just go through that. First of all, again, it's a percentage, right? So what we're going to do is we're going to divide two things and multiply by 100. So what we end up doing is we end up saying this. We take the grams of an element and we divide that by the grams of the compound, meaning the molar mass of the object. And we multiply by 100. Why? Because it's a percent. So I'm going to do a couple of examples and then we'll go from there. So number one. Number one says 8.20 grams of magnesium combines with 5.40 grams of O2. So what you end up having is for the percent composition, and the percent composition we're going to do first is we'll do the magnesium. Well, the grams of the element magnesium I just told you was 8.20 grams of Mg, right? The grams of the compound, however, I told you I have 8.20 grams of Mg and 5.40 grams of oxygen, which would be O2, times 100. So you do the math on this, 8.20 divided by 8.20 plus 5.40. You round to the hundredths place, I have 60.29%. Round to the hundredths place because that's what we do with percentages. Now I have two choices here. I can calculate the oxygen, which I'll just do, percent of O2, which is equal to 5.40 grams over 8.20 grams of Mg, this is grams of O2, plus 5.40 grams of O2, right, times 100, and that equals 39.71%. Now, the other option that I had here is if I knew that 60.29% was one thing and there was only two things in it, then it leaves the remaining percentage, 39.71%, to be the rest of it. So I could have just taken 100 minus 60.29 and gotten 39.71. Whatever. Number two, it says calculate the percent composition of each element in K2 Cr2O7. So let's start with the percent potassium first. So when we look at this compound, we know we have two potassiums. So what I'm going to do is I'm going to take 2 times. I'm going to go to the periodic table, and I'm going to find the molar mass of potassium, okay? And it's 0.98, right? So what I end up with is 2 times 39.098, right? Over the molar mass of the entire thing, K2Cr2O7, because we do the grams of the molar mass of the compound. And that's 294.18. I do the math on this, multiply it by 100, right, because it's a percent, and I get, I have 26.58%. All right, the percent of the Cr now. Well, there's still 2 of them. So it's going to be 2 times the molar mass of chromium, which is, boy, I'm making this hard on myself. I don't know. It adds up to 103.99. So I assume they're both like, I don't know, 51.98, something like that, 51.99. But anyway, when you take 2 of them, you get 103.99. Over 294.18, because that's the total of the whole thing, times 100, and that's equal to 35.35%. Now, we have a choice on this last one, right? We could just do that 100 thing. We could subtract 100 minus 35.35 minus 26.58, or we can just calculate it. Let's just calculate it. So oxygen, there are 7 times 16 over 294.18 times 100, and that's equal to, you do the math on it, and you get 38.07%. And that is how you do percent composition. It is easy.